Every year, the world produces more than 410,000 tons of silk, according to International Sericultural Commission. Yet it all begins with something fragile: the cocoon of a silkworm no bigger than your thumb. To make just 1 kilogram of silk, it takes about 2,500 silkworms, each spinning a single thread nearly 1 kilometer long. This material was once reserved for emperors and royalty, discovered, legend says, when a cocoon fell into a cup of tea in ancient China. Today, inside modern factories, thousands of cocoons move through heat, water, and machines that reel their delicate threads into one of the most luxurious fabrics on Earth. Silk has shaped human history for more than 5,000 years. Ancient records show it first appeared in China, where farmers learned to raise silkworms and harvest their cocoons by hand. For centuries, silk was China's best-kept secret, carried westward only through merchants on the Silk Road. By the 13th century, production had spread to Italy and France, giving rise to Europe's first textile guilds. In the United States, silk became popular during the Industrial Revolution when mills in Pennsylvania and New Jersey began spinning imported cocoons into fine fabric. Today, China still produces over 2/3 of the world's silk, while Thailand and India preserve hand-weaving traditions that give each piece its own character. From royal robes to neckties and parachutes, silk has evolved with time but never lost its mystique. So, how do millions of tiny cocoons transform into the smooth, shimmering fabric we wear today? The journey of silk begins long before a single thread is spun. Inside temperature-controlled incubation rooms, adult moths are carefully bred to produce strong and uniform offspring. Female moths lay hundreds of tiny eggs, each no bigger than the head of a pin. Workers collect and place them on special trays lined with paper or mulberry leaves. The air is kept at around 77 degrees Fahrenheit with balanced humidity to help the eggs hatch evenly. Within a week, the larvae emerge and immediately begin feeding. Factory technicians monitor the conditions around the clock to prevent disease and ensure synchronized growth. Every batch is logged and tagged for traceability, so each silk reel can later be traced back to its origin. Precision at this stage determines the quality of every fabric made later. But once the eggs hatch, how do these tiny worms grow large enough to spin a kilometer-long thread? Young silkworms spend most of their short lives eating. Their only food is fresh mulberry leaves, which are hand-picked every morning and sliced into thin strips. Workers deliver them to large trays stacked across metal racks, filling the rearing rooms with a green, earthy scent. Each worm eats almost non-stop for about 25 to 30 days, growing more than 10,000 times its original weight. The environment is kept warm and slightly humid to mimic early summer conditions. Cleanliness is crucial, so trays are cleaned and replaced daily to remove droppings and dry leaves. By the fifth molting stage, each larva is plump, pale, and ready for its most important task. The gentle rustling of leaves fades as the worms stop feeding and begin searching for a quiet place to spin. So, how do they turn a simple leaf diet into one of the most valuable fibers in the world? When fully grown, silkworms begin to secrete a liquid silk protein called fibroin from glands in their heads. As it touches the air, it hardens into a continuous filament. Each worm spins in figure-8 motions, wrapping itself layer by layer in a soft golden shell. The process lasts 3 to 4 days, creating a cocoon made from a single thread stretching nearly 900 to 1,500 meters. Inside, the worm prepares to transform into a moth, but before that can happen, the factory steps in. Workers carefully collect the cocoons by hand or suction systems to avoid damage. Each one is sorted by color, size, and density. Larger, uniform cocoons are prized for producing smoother, stronger threads. This delicate balance between biology and timing defines the first moment silk truly takes shape. Can you guess how many cocoons are needed to make just one skein of silk? To preserve the silk inside, the cocoons must be treated before the moths emerge. They are placed inside large steam chambers or immersed in water heated to about 194 degrees Fahrenheit, 90 degrees Celsius. This kills the pupae and softens a natural glue called sericin that holds the filaments together. The room fills with warm mist and a faint nutty smell as the proteins dissolve. Once cooled, the softened cocoons are ready for reeling. Technicians unwind several filaments at once to form a single, stronger thread. On average, it takes about 5,000 cocoons and 30 hours of careful work to produce one skein of raw silk. Every reel is tested for thickness and elasticity to ensure consistency. The result is a shimmering strand so fine that breaking it by hand is nearly impossible. But how do factories keep these fragile threads from tangling or breaking during high-speed reeling? In the reeling section, workers guide the softened filaments onto mechanized spools, rotating at high speed. Each thread passes through tension sensors that ensure it stays even and smooth. Once reeled, the raw silk is washed to remove remaining sericin, leaving a soft, glossy finish. Depending on the product, the threads are dyed using natural pigments or chemical dyes inside heated stainless steel tanks. For darker tones, the bath may reach 185 degrees Fahrenheit, 85 degrees Celsius, to lock in color. After dyeing, the silk is twisted and combined into multiply yarns for added strength. The rhythmic hum of machines and the sight of hundreds of spools turning in unison create a mesmerizing factory scene. Operators check every reel under bright light for color consistency and uniformity. Now that the silk threads are strong and colored, how are they woven into the smooth fabric we know? The final stage transforms threads into cloth. On automated looms, Thousands of silk strands are stretched across steel frames called warps. Shuttles carrying the weft threads move rapidly between them, sometimes over 500 insertions per minute. As the looms operate, the rhythmic clatter echoes across the hall, blending technology with tradition. Finished fabric rolls are washed, stretched, and pressed through heated rollers to achieve a lustrous sheen. Quality inspectors examine every meter under white light to catch knots or uneven weaving. A flawless roll may measure up to 3 meters wide and weigh just a few kilograms. From here, the silk can become shirts, ties, or luxury bedding. Its journey from cocoon to cloth is complete, a process that began with a single insect and ends with one of humanity's most treasured materials. So the next time you feel a piece of silk between your fingers, will you picture the millions of tiny workers behind it? Every year, Americans buy more than 450 million pairs of jeans, according to Grandview Research. That's more than one pair for every adult in the country. What started as simple workwear for miners has become a global fashion worth over $70 billion. Yet behind every pair lies a complex industrial process involving cotton fields, high-speed looms, and even laser machines that age denim in seconds. From dusty farms to roaring factories, every stage must be precise to create that perfect blue fade. So, how does raw cotton turn into the rugged jeans that have defined American style for over a century? The story of jeans began in the mid-1800s, during the California Gold Rush. A tailor named Levi Strauss used durable cotton fabric called denim to make tough work pants for miners. To prevent tearing, he reinforced stress points with small copper rivets, creating the world's first blue jeans. By the early 1900s, denim pants became standard for farmers, railroad workers, and mechanics across America. After World War II, jeans left the factory floor and entered pop culture, worn by movie icons like James Dean and Marlon Brando. The fabric's deep indigo color and fading lines soon became symbols of rebellion and youth. As global production expanded, new dyeing and washing methods gave each pair a unique look. Yet even after more than 150 years, the classic 5-pocket design remains the same. So, what happens inside a modern factory where raw cotton becomes the world's most popular fabric? Every pair of jeans begins in a cotton field. Modern harvesters, called cotton pickers, can collect as much fiber in 5 minutes as one person could gather in an entire day by hand. The raw cotton is packed into massive rectangular bales weighing around 200 kilograms each. Once delivered to the mill, the bales are opened, loosened, and cleaned. Powerful blowers remove dust, leaves, and seeds as the fibers move through a series of rotating drums. The air smells faintly of dry earth and fiber as thousands of strands swirl under bright industrial lights. By the end of this stage, the fibers are soft, white, and ready for spinning. Each cleaned bale provides enough cotton to make about 325 pairs of jeans. The material looks simple, but consistency here is key. If the cotton blend is uneven, the final fabric will show it. But how does this fluffy white mass become the strong blue fabric we know as denim? The next step transforms raw fiber into yarn. In the spinning hall, machines stretch and twist cotton slivers at speeds reaching 120,000 revolutions per minute. The fibers align, tighten, and emerge as long, uniform threads wound on large spools. For denim, the yarn must now turn blue. Workers feed the spools into giant dyeing towers filled with indigo solution. As the yarn rises and falls through each vat, oxygen in the air turns it from green to deep blue. The process repeats several times to reach the perfect shade. Finally, the threads pass through a drying tunnel where heated rollers remove moisture and smooth the surface. Each strand is coated with a thin layer of starch to improve strength during weaving. The result is a crisp, dark thread ready for the loom. So, how do factories weave thousands of these blue threads into sturdy denim fabric? Inside the weaving room, the sound of machines fills the air. Hundreds of warp threads stretch across steel frames while weft threads move back and forth through them. This tight cross weave creates the diagonal rib pattern that gives denim its strength. Typically, 3 blue warp threads are woven for every 1 white weft thread, which is why jeans fade to white when worn. Each loom can produce around 3,000 meters of denim per week, enough for nearly 2,000 pairs of jeans. Workers monitor the tension and replace broken threads within seconds to avoid defects. Once woven, the rolls of fabric are brushed and heat-treated to stabilize the weave. The finished material is firm yet flexible, with that unmistakable raw blue look. Can you guess what happens next when giant rolls of fabric meet precise computer-guided cutters? In the cutting hall, massive tables stretch for more than 30 meters. Layers of denim, sometimes over 150 stacked sheets, are spread evenly. A digital pattern, designed to minimize waste, is projected onto the top layer. Then, an automatic blade slices through all layers in minutes with extreme precision. One roll of fabric can produce about 350 pairs of jeans. The cut pieces move to the sewing room, where around 300 workers operate heavy-duty machines. Each person handles one section: pockets, zippers, or seams. Stitching happens fast and loud, as machines hum in rhythm. Strong polyester threads hold the thick denim together, forming the classic 5-pocket structure. After several inspections, the jeans are ready for finishing. But that rugged, faded look doesn't come from time. It's created inside the factory. How do they make new jeans look worn? The finishing stage gives jeans their personality. Some are treated with lasers that burn precise fade marks, whiskers, and even small rips. Others go into massive drums for stone washing, where pumice stones rub the denim surface for hours to soften and lighten the color. Newer plants use ozone treatment, a cleaner process that fades indigo using natural gas instead of water or chemicals. Workers adjust every shade carefully, from dark indigo to vintage light blue. The smell of wet fabric, steam, and metal fills the air as the jeans tumble, rinse, and dry. Each pair passes through dryers heated up to 160 degrees Celsius, 320 degrees Fahrenheit, before being pressed flat. The process makes every piece look unique. No two pairs are exactly the same. So after shaping and fading, what happens before those jeans reach the store shelf? Before leaving the factory, every pair is checked in detail. Inspectors examine seams, rivets, zippers, and measurements under bright lamps. Any irregular stitch or loose thread is repaired by hand. Buttons and labels are attached using pneumatic presses that deliver precise pressure for every brand logo. Each finished pair is folded, pressed, and tagged with size and barcode information. Finally, the jeans are packed in boxes of 20 or 50 pairs and sealed for shipment. A single factory can produce up to 6,000 pairs a day, all meeting strict quality standards. When the boxes roll out on the conveyor, they carry a piece of American heritage, denim born from cotton, steel, and precision. Next time you pull on your favorite pair, will you think of the long path it took from field to factory floor? Every year, the world's leather industry processes more than 1.5 billion animal hides, according to FAO stat. From those hides come millions of jackets, shoes, and accessories, but none more iconic than the Harley-Davidson-style leather jacket. It's not just clothing. It's a piece of American road culture, built to survive wind, rain, and years of wear. What makes it remarkable is the transformation behind it. Raw, salted hides turned into soft, flexible leather that looks aged but never weak. Inside modern tanneries and workshops, chemistry meets craftsmanship in a process that can take weeks to perfect. So, how does a tough animal hide become a symbol of freedom on the open road? The leather jacket's story begins in the early 1900s, when aviators and motorcyclists needed protection from cold wind and road debris. In 1928, a New York tailor named Irving Schott designed the first motorcycle jacket, later known as the Schott Perfecto. It was made from thick horsehide, fitted with metal zippers, and built to last through rough rides. During World War II, pilots wore similar leather flight jackets lined with shearling for warmth. After the war, the style hit the streets. Movies like The Wild One and Rebel Without a Cause turned the jacket into a symbol of rebellion. By the 1950s, it wasn't just for bikers. It became part of American identity. Today, modern versions still follow that same blueprint, combining classic design with advanced tanning and finishing techniques. So how do factories turn heavy raw hides into smooth, flexible jackets ready for the open road? Every leather jacket begins with raw animal hides, usually from cows or buffalo. The hides arrive at the tannery in a salted or frozen state to prevent decay. Workers inspect each piece for thickness, scars, or branding marks that could affect quality. The best ones are selected for jacket production. The hides are soaked in large rotating drums filled with water and mild detergents to remove dirt, blood, and salt. The process can last up to 8 hours depending on the hide size. Next, they are treated with lime and sulfide to loosen hair and fat, making the surface soft and workable. Machines scrape off the remaining hair, while jets of water rinse away residue. The hides now look pale and rubbery, ready to be transformed into leather. Precision at this stage decides how smooth the final jacket will feel. But how do these soft skins become durable leather that can last for decades? Tanning is the chemical process that turns perishable skin into long-lasting leather. Inside massive wooden drums, the hides rotate slowly while soaking in special tanning solutions. Two main methods dominate the industry: vegetable tanning, which uses tree bark extracts for firmness, and chrome tanning, which uses chromium salts for flexibility and speed. For motorcycle jackets, chrome tanning is preferred because it makes leather soft, yet resistant to weather and abrasion. The process takes about 24 hours of continuous rotation. Once tanned, the hides are rinsed, stretched, and dyed inside the same drums to ensure deep and even color. Most biker jackets use black or dark brown shades achieved through oil-based dyes. Workers then hang the hides in drying tunnels at 100 degrees Fahrenheit, 38 degrees Celsius, for several hours. The material that emerges is tough, slightly oily, and full of character. Now that the leather is stable and colored, how do factories cut it into precise shapes for a jacket? The tanned leather is flattened, graded by thickness, and passed through a rolling press to even its surface. Designers create digital or paper patterns that include every part of the jacket: front, back, sleeves, pockets, and collar. Using computer-guided knives or laser cutters, workers arrange the patterns to minimize waste. Each hide is unique, so operators must avoid natural flaws like wrinkles or holes. Cutting machines slice through the leather with high pressure, producing sets of panels ready for stitching. A typical jacket includes 20 to 30 separate pieces, each labeled and bundled together. Even the smallest components, like belt loops or pocket flaps, are cut from specific sections of the hide to maintain consistent grain. The cutting floor smells faintly of tanned leather and oil. Every move is measured because one mistake could ruin an entire hide. But once these pieces are ready, how do they come together to form the jacket's iconic shape? In the sewing room, the sound of heavy-duty machines fills the air. Skilled operators use walking-foot sewing machines that can pierce thick leather with waxed polyester thread. The process begins by joining the front and back panels, followed by the sleeves and inner lining. Each seam is double-stitched for strength, while edges are folded and pressed flat with heated irons. The famous features of a Harley-style jacket, angled zippers, snap-down lapels, shoulder epaulets, and waist belt, are added during this stage. Metal zippers and rivets are attached using pneumatic presses that apply precise pressure. Inside, a quilted or polyester lining is sewn for warmth and comfort. Some factories add extra padding at the elbows or shoulders for protection. By the time the jacket leaves this room, it already carries its signature look. But to get that broken-in vintage feel, the leather still needs one more transformation. Finishing gives each jacket its unique character. Workers apply natural oils and waxes to restore shine and flexibility. Some are hand-rubbed, while others go through mechanical tumbling drums that soften the leather through friction. To create the aged Harley look, artisans lightly sand or brush certain areas, simulating years of wear. Others use heat and pigment sprays for deeper tones and highlights. Once finished, the jackets are hung on heated mannequins to set their shape and fit. The final step is inspection, checking seams, zippers, and color consistency. Each jacket must meet strict standards before receiving its brand label. Finally, it's folded, wrapped in fabric covers, and packed for shipping. In total, the process from hide to jacket can take up to 2 weeks. Next time you zip up a leather jacket, will you picture the drums, heat, and hands that shaped it? Every year, the world buys more than 1.4 billion pairs of sneakers, according to Statista. That's almost one pair for every adult on Earth. Behind those lightweight shoes lies a high-tech process involving digital design, chemical molding, and robotic assembly lines. In some factories, machines can shape midsoles from foam heated to 160 degrees Celsius, 320 degrees Fahrenheit, while lasers cut fabric patterns with millimeter precision. What used to take skilled shoemakers days now happens in minutes. Yet even with automation, each sneaker still passes through dozens of human hands. So, how does a simple sketch become the pair of sneakers you tie every morning? The modern sneaker was born in the late 1800s, when rubber soles first met canvas uppers. The U.S. Rubber Company launched one of the earliest mass-produced shoes in 1892, later known as Keds. But it was in 1917 that the Converse All-Star changed everything, combining flexibility, grip, and comfort. By the 1920s, sneakers had moved from gym floors to city streets, becoming a symbol of youth and energy. But what exactly happens inside those massive facilities that turn sketches and raw rubber into the shoes we wear every day? Every sneaker begins on a computer screen. Designers create 3D digital models, testing hundreds of color and material combinations before a single shoe is made. Each part, the sole, upper, and lining, is chosen for a specific purpose. Lightweight mesh improves breathability, while leather or synthetic panels add structure. Engineers simulate how the shoe flexes and absorbs impact using CAD software. Once the design is approved, factories source raw materials: rubber for soles, fabric for uppers, foam for cushioning, and metal for eyelets. All materials are inspected for consistency and durability before entering production. Nothing moves forward without meeting strict weight and strength tests. The air smells faintly of rubber and glue as workers prepare rolls of fabric and sheets of foam for cutting. Precision at this stage sets the foundation for every pair to come. But how do these materials transform into the shape of a shoe? The upper is the most visible part of a sneaker, and it starts with precision cutting. Large sheets of fabric are placed on laser cutting tables. Guided by digital blueprints, lasers slice each panel with millimeter accuracy, producing up to 600 pieces per hour. In traditional factories, workers still use metal dies to stamp out shapes from leather or suede. The cut panels then move to the stitching section. Skilled operators use industrial sewing machines to join the pieces, layer by layer, forming the toe box, tongue, and sides. Reinforcement tape and mesh inserts are added to strengthen stress points. A single upper can require more than 50 individual stitches. Once finished, it's steamed and shaped over a mold called a last to give it a clean, 3D form. So, what happens next when the upper meets the sole, the heart of every sneaker? The sole is where science meets comfort. In a separate section, giant mixing machines blend polymers, rubber, and foaming agents to create midsoles. The mixture is poured into aluminum molds, heated to about 160 degrees Celsius, 320 degrees Fahrenheit, causing it to expand like bread dough. Within minutes, it cools into lightweight, flexible foam known as EVA or polyurethane. But how do these separate parts fuse together with perfect alignment? This is where the sneaker finally takes shape. Workers place the finished upper over a foot-shaped mold called a last. The edges are stretched and glued to fit perfectly around the sole. Industrial presses apply heat and pressure, activating adhesives that bond the materials at over 150 degrees Celsius, 302 degrees Fahrenheit. Robotic arms position the soles, while sensors ensure every layer aligns precisely. Once bonded, the shoes pass through a cooling tunnel to lock in shape. Technicians then attach insoles, eyelets, and laces. Some factories can assemble up to 25,000 pairs a day, each pair moving through more than 100 checkpoints. Every sneaker is flexed and twisted on mechanical testers to ensure it can handle months of daily wear. Still, a sneaker isn't ready until it passes one final and critical phase. In the finishing room, sneakers receive their final touches. Workers trim excess glue, clean smudges, and check stitching under bright inspection lamps. Each pair goes through fit testing and weight comparison to ensure both shoes match perfectly. Logos and size labels are heat-pressed or laser engraved. Some brands add deodorizing spray or insert foam forms to maintain shape during shipping. Every batch must pass durability tests, twisting, bending, and compression cycles that simulate 30,000 steps of use. Only flawless pairs move to packaging. Inside the warehouse, conveyor belts line up boxes, each labeled by size and destination. A single factory can pack over 50,000 pairs daily. From design to delivery, the process combines engineering, craftsmanship, and precision. So the next time you lace up your sneakers, will you picture the machines, molds, and hands that built them? From delicate silk threads to rugged denim, from tough leather jackets to high-tech sneakers, every product we explore today tells a story of transformation. What begins as something raw, simple, or even ordinary, cocoons, cotton, animal hides, and rubber, becomes something extraordinary through human skill and machine precision. Each material passes through fire, pressure, and time, until it finally takes the form we recognize and use every day. In silk factories, thousands of tiny worms spin a single shimmering thread that becomes luxurious fabric. In denim mills, cotton from vast farms turns into jeans that have shaped American style for more than a century. In tanneries, raw hides are tamed by chemistry and craftsmanship to create jackets that carry the spirit of freedom. And inside sneaker plants, robots and artisans work side by side, crafting shoes that define movement, comfort, and identity. Behind every product we wear or touch lies a world of hidden labor, machines humming, workers focusing, and traditions passed through generations. These factories may look modern, but they preserve something deeply human, the desire to build, create, and perfect. That's what makes manufacturing not just an industry, but an art. If you've ever wondered what's behind the things you use every day, this is where the answers begin. Subscribe to Captain Discovery and join us on the next journey inside the world's most fascinating factories. From food to fashion, from steel to silk, we'll keep uncovering the secrets of how it's all made. Because every product has a story, and every story deserves to be discovered.